Good morning, or good afternoon. So I would like to welcome you to thematic session 6, which is called Particle Physics and Study of the Universe. And I am very happy to have 5 speakers who will give us a view of different fascinating projects in the domain of particle physics and astronomy. Of course, there are many others that we would have liked to invite, but there's not so much time in this Congress, and there are parallel sessions taking part at the same time. But I think that we have selected a very good group of speakers who are coming from organizations who are working intensively with industry and are committed with projects that involve collaboration with our industry and our companies. So I'm very happy to have them here. I'm really grateful. So international research infrastructures in physical science are engaged in very exciting projects that will see the light of day in the near future. For example, in the field of astronomy, we have a significant global breakthrough which is expected, which is the Extremely Large Telescope by ESO. Alain is going to give us a view of that. In the domain of particle physics, the ESS is in the final stages of construction and getting ready for its beam on target. We also have 2 speakers from CERN who are going to talk about different projects. Cristina is going to give us a more overall view about procurement at CERN and upcoming opportunities. And then Luis Miralles on her right is going to talk about the future, which is the FCC, and the present, which is CERN's contribution to the Dune experiment in the United States, also with a significant contribution from Spanish companies and still some upcoming opportunities in the pipeline. And then we have Mario Martinez, who is representing the Einstein telescope. We had a talk yesterday by a colleague from CERN talking about the cryogenic and vacuum challenges in the ET and the experiments that they are doing there. And Mario is going to give us a more overall view of the project. It's very fascinating and lots of opportunities for industry also in the coming years, but also in R&D presently. So I hope you enjoy the session. The session is going to evolve through presentations, and you can ask questions at the end of each session. I would like it to be interactive, of course. So just a brief introduction about ourselves. We are CDTI. We are the industry liaison officer for all these organizations that you see there in the chart, and also partner of the ETPP preparatory phase project. We are also partner of ImproCap, which is a European project in which we try to foster good practices in innovative procurement using PCP and PCI in big science, and there was a talk about that before in the plenary session. And I have included there some useful links which you can use. Specifically, a very good resource is the BSBF Procurement Handbook. The last one was published for the Trieste edition, and it contains information about all the procurement rules, how industries have to access these organizations, how IPR is managed, technology transfer, and so on, for the different member organizations of BSBF. We also have the resource about the ImproCap project, as I mentioned, and then our own resources, like our mailing lists, if you want to receive information about procurements, and also the catalog of Spanish companies which are active in big science facilities. You can find it at our booth. You can take one if you want, or there are also some leaflets. Next, please. I have my, here it is. Okay, so this is the main screenshot of the catalog. It's online in our website. It's a public resource. You can use it to find partners, to find institutes who can collaborate with you in the different projects, and also to find information about the national research infrastructures in Spain with capabilities. For example, here there is a screenshot. You can see the link there at the bottom. And this is the introduction, so thanks a lot. And I'm going to welcome my first speaker, who is Alain Delorme, there at the right. A short summary of his trajectory. He joined ESO in 2010, and he is presently the acting head of the Contracts and Procurement Department at ESO since the beginning of 2024. Alain has a background in economics with an extensive experience in sales and business units, and he took over purchasing responsibilities from 2002 in France and abroad. He is specialized in public procurement with lots of experience. So Alain, you're going to take us through the different project of ESO. I think that you're going to stop in the ELT more specifically, and the floor is yours. Thanks a lot.
Thank you, Javier. Can you hear me well? Okay, buenas tardes a todos. Good afternoon. So, about ESO, there was a presentation already by Javier Barcons, my DG, so yeah, you're here. I will try not to repeat. Okay, so ESO focusing on the procurement part. So this is a nice view of our facilities. What is ESO? We design, and I'm focusing on the procurement. We design, build, and operate world-class observatories on the ground. We foster astronomy, but I did not address here. It was already said this morning. The astronomers worldwide use our telescopes to do science. We are an international organization established in 1962, supported by 16 member states currently, and Spain, it was mentioned this morning, joined in 2007. So we are based in Garching by Munich. It's 15 kilometers north of Munich in Germany. And all our premises, observatories are in Chile. We have the offices, local offices in Santiago de Chile, which is in the middle of Chile. We have the first site, La Silla, close to La Serena, north. And we have the VLT Cerro Paranal. We are building the VLT at Cerro Armazones. And we are partner in ALMA project at the top north of Chile. And very important in terms of procurement, we are not subject to any national law, not even the German one, because of our status as international organization. This has an impact, I will come to this. So we use taxpayers' money, so we apply the public procurement principles. Competition is the rule, single source the exception. And we have to treat the bidders equally and fairly, of course, and have full traceability. However, we are not subject to the EU, the European Union procurement rules. So we do not have the same traceability, the same right of appeal when we award contract. We do selective tendering, meaning that we select the companies we invite. Even if you would apply, we could say no. And in particular, I will come to this, in the role of the ILO, we can have a selection. We have, actually, a selection, in particular for Spain. We procure, in principle, to the ESO member states only. There are exceptions, but it's mainly to ESO member states. And of course, we procure from time to time for local procurements in Chile and only in Germany when it can only be delivered locally. We have this constraint at ESO because we want to give the same chances to all the ESO member states that we can invite only 5 companies per member state. So in Spain, it's usually problematic. You are limited. Javier has to make a selection. He is the one to decide. I mean, CDTI is the one to decide. So I know it's a choice which is difficult from time to time. And the message here is to tell you that in case you would be invited and you cannot offer or you do not have the capability or you do not have the time, please decline or opt out. This will give a chance to another Spanish company. Otherwise, the place will be blocked and nobody, the number 6 or number 7, will be able to apply. So we ask you to collaborate here to give more chances to Spain. Okay. The competitive calls are published on the ESO website and on the ESO procurement portal that we use since November 22. Yes, November 22. And so everything above 50,000, you don't know the value. We do not give any indication of the price or of the budget. It's not our rule. We award the contract to the bidder which offers the best value for money. And in some cases, when it's very simple goods, or off-the-shelf goods, for example, or basic services, we apply the lowest price compliant principle, LPC. Also important, we do not have an industrial policy. We do not intervene into the selection of the subcontractors from the main contractor or the prime contractors that we contract. This is very important. We have no say. Sometimes we put some rules that they need, and in particular for the big contract, they need to procure at least a certain percentage in the ESO member states plus Chile. And there was one case, the biggest contract ever, which was for the ELT, where there was an obligation to procure in some countries, and Spain was one of them. But otherwise, we do not apply any obligation as to the choice of the subcontractors. Some figures over the past 5 years, and I'm taking 5 years because we placed the ELT contract, the biggest ever, as I mentioned, 10 years ago. So to remove this big peak in the procurements, I've calculated here the 5 years, we have procured in average 109 million euros. This is a quite stable figures and should be stable in the coming years, perhaps going slightly down. With Spain industry, over the 10-year period 2024, ESO has placed contracts for a value of 84 million euros, so direct contracts, and we have paid so far 59 million euros. If now I look at the return, we have to report to our member states how much goes back to Spain, I mean, in particular, but to all member states. Spain is pretty well. You have the blue bar here, which is calculated over 10 years, which is the period we look at. And Spain is above the target, because we have a target of 0.7. So how is it calculated, this zero return? We take the proportion of the contract, we divide by the proportion of contributions. If you are at 1, it means that it's equivalent, you have the same proportion. If you are below, you don't have the same proportion, but the minimum is 0.7 because we have, usually we procure between around 30% in Chile. So even if this is calculated only based on the member states, the target can only be 0.7. There is no obligation of just retour, contrary to ESA for some projects, but we aim at a fair distribution. So in the long range, we try to influence such that we would manage, but it's relatively difficult. You can see on some of the countries, it's quite difficult, but we try to influence more or less the return. Some examples of contracts that we have placed in the past. Sener had a very important contract in value for the ELT M2 and M3 cells, and also the M1 manipulator. We have IDOM in the Basque Country, which was awarded the local co-answer, the PDS also. Procon Systems got this contract for electronics cabinets for the ELT, M1 cell, plus another contract, or several other contracts. Mecánicas Bolea, Argos Technical Assistance, and as I mentioned, the big contract for the ELT, which was won by an Italian company, Cimolai, Acce, but Cimolai has taken over, contracted Astur Feito for the M1 crane bridge. And of course, Spanish institutes are also involved in several instrument consortia. Okay, this is Paranal. Opportunities. So first, some background. We are currently at the end of the ELT procurement. It was mentioned by Xavier this morning that we have completed 70% of the construction of the ELT, but we have procured more than 98%. So it means that basically what remains will be in Chile, because we are installing in Chile, and it will be the last-minute change request, technical assistance that we will need on site. And there is a financial pressure to complete as fast as possible, and of course within the cost to complete, which means that the new major project mentioned by Xavier this morning, Expanding Horizons, is only in the early stage of preparation, but the actual procurements will not come before the 30s. Nevertheless, we still have a few current projects, the ALMA Wideband Sensitivity Upgrade, WSU, but it is true that most procurements have already been engaged, so opportunities are not so much. And we have the IOP, ISO Integrated Operation Program, which will cover the common integration of Paranal and the ELT, and this is where we have the main opportunities. So, okay, that's the aim of this. So we will have needs in terms of automation, monitoring equipment, integrated security system for Paranal Observatory, integrated resource planning tool, consultancy support, a lot of consultancies everywhere because we need support to determine what we can do based on what we have today and what we should do to improve. Basically, we want to digitalize everything and go from a paper-based process and work packages, etc., to fully digital and based on processes. We will also need integrated planning tools, logistic tools. We want to introduce a product lifecycle management system and set up digital twins, mostly BIM, plus photographic digital twin. So this is a list. Also, it establishes a lesson learned database, have a remote medical diagnosis, because we are in the middle of nowhere in the desert, and we need a capacity to do pre-check, medical check in case of problem. It can happen, and it has happened, unfortunately. And yes, okay, so that's for IOP. We also have some opportunities: solar cooling system, turbulence monitoring units, sky quality monitoring units, in situ washing, cleaning of ELTM1 mirror. There was an RFI issued already, I think, 2 years ago, but we have progressed in the definition of the need and the possible solution, and we will relaunch the RFI in the coming weeks. We will need some hexapod controllers, new hexapods for the ALMA antennas, and large mirror transport trailer, booms, lift, a few things for operations. Corporate, we will have need for an electronic document management system, central identity and access management solutions, training in various areas, and this is all the time, this is a recurring need. And as mentioned this morning, since our old observatories are getting old, and very old, so for some of them, we will need to manage the obsolescence with new hexapods, I mentioned, various control systems, cryogenic equipment, and various electronics. So this is a quite large and fuzzy list. I acknowledge that. But this we will publish soon, at the end of the month, before the end of the month, the list of procurement we want to engage with some indication, more detailed indications, and it will be available on the procurement portal. So I invite you all to register or check whether you are registered or not. Okay, challenges. This is a recent photo of the ELT end of October. Challenges. First thing, are you registered on the ESO procurement portal? If not, you come to me, I give you the QR code, you can scan, and you can register. And if you don't know whether you are registered or not, you ask me, I will check whether you are. Important, are your contact details up to date? Because if you are registered, but the person has left the company, then you do not receive the notifications. The third thing, did you select the right business classifications which allow you to receive the notification in the field you are on? This morning, for example, I was with the company and the selected categories were not complete, and even one was wrong. Then you receive a notification and you say, but that's not for me. So this is important to select the right business classification. As I mentioned, the opportunities are published, and we have also the ILO details, but I think it's everybody knows you. And we have also some guides which we encourage you to read before you register or when you are registered, but also, and more importantly, when you want to submit or plan to submit an offer. Now, when you are invited and want to submit an offer, or do not want, first, as I mentioned before, please let us know if you are interested or not. You can reject the invitation or confirm and opt-in, opt-out. Do not hesitate to raise any question you can have, because if you receive our documents, most of the time, our documents, you will not fully understand. You will say, oh, what is missing? What do they want here? Ask the question. Don't hesitate to ask the questions, because if you you start offering based on assumptions which are wrong, then we have a problem later on. Your offer will not be valid, or we'll have a dispute. So it's very important to ask any question when you have any doubt. And this is done during using the correspondence function in the portal. Check carefully the evaluation criteria and provide all the information we ask for each of the criteria. Do not wait the last minute. We have cases where 10 minutes before, oh, I cannot submit my offer. Don't wait, because 10 minutes before, nobody will be able to help you. And of course, very important, you will be in competition. It's not only with Spanish companies, it's with all the member states companies. So your offer needs to be the best from the beginning. We do not engage into systematic negotiations with the bidders because we are bound by the public procurement principles. So you make an offer, and this is supposed to be the best. So don't expect, oh, I put some margin because I will negotiate later. That's fine. No, don't do that. Put the best offer initially. Otherwise, you might miss the opportunity at all. And yes, very important as well, when we ask for inputs, documents, give everything also from the beginning. If a major document is missing, or unclear, or really a one-page document while we expect something serious, we'll consider you as non-compliant, because you will not have provided the serious information and documents which allow us to assess your offer on a sound basis. So it is very important to look at the offers, at the request for offer, initially, rapidly, to check what is required by ESO, to prepare everything so that you do not miss at the end at the closing date. The QR codes to access, I think it's impossible to scan from here, our sites, and thank you.
Yeah. Christina now. Thank you, Alain. It was very interesting. I think you gave a very clear view of the procurement rules of ESO and also the upcoming opportunities. And I have to say that ESO, I think, is a very demanding customer. I have discussed this with Alain quite a lot, but it's also true that companies that have worked for ESO have really pushed forward in their innovation, and it's, in general, very good experiences. And also, I would like to add that sometimes it can seem a bit daunting to apply for a project which is going to take part maybe in Chile or in Germany in the headquarters or whatever, but in the end, there are not so many bids sometimes for the procurement. Don't think that for the fact that there are 16 member states and companies from all the states, sometimes there's not so much competition. So it's really a good opportunity for companies. It's true that ESO is in the final stages of the procurement of the ELT. Now they are super busy themselves building it, but there are still some interesting opportunities, specifically in the IOP. So thanks a lot, Alain. If you could give a few words about the technology development program in ESO, okay, and explain a little bit about that.
What is it? C'est bon.
Yeah, c'est bon. Technology development program. Yes, it was created at ESO about 10 years ago with a twofold purpose. The first was to develop and secure key technologies for future programs to be used in future programs. So we want to de-risk these technologies, and also in some cases to develop some standards at ESO. It is true that, however, we are quite limited, and Javier mentioned it this morning, we are quite limited in budget. We are talking about 1.1 million euro budget per year, 12 FTEs, full-time equivalent people. So it's a bit limited. So the only way to contribute and to have something meaningful is to have to do it in collaboration. And also we are, and it was approved 2 days ago, or yes, 2 days ago, to apply GTO, to collaborate with institutes, and we would help them to develop with us, and in return, in compensation, they would get some observation time on the telescopes. So it means that for this, due to the limited means, we cannot have a usual or standard procurement approach with industry. We have to collaborate mainly with institutes. That's a limitation.
Thank you, Hélène. Thank you. Okay, let's go with our next presentation by Cristina Lara. Cristina is Head of Contracts and Procurement in CERN. Head of the Procurement and Industrial Services Groups at CERN. She leads procurement projects representing an annual volume of approximately 670 million Swiss francs. And Cristina manages a multidisciplinary team of 40 procurement professionals. So thanks, Cristina, for coming. I know you are very busy, and the floor is yours.
Thank you. I have many slides, and I have seen that we have a few things in common with ESO. So I'm going to try to identify where we are similar and where we are not similar. First of all, just 2 words on myself. I know very little of CERN. I've only been there for more than 30 years, and there is plenty of places where I still have to learn, so I'm still learning every day. Before I get into what we are buying, I'm going to have a very short introduction on the CERN. I know that Mark gave this morning an introduction on CERN, and he is going to give you a few figures, some statistics of what we buy, how we buy it, what's the impact of doing business with CERN, what is important for you to buy at CERN, and some other tips that I will try to share with you. CERN is the world's largest laboratory for particle physics. It was an organization established more than 72 years ago, Science for Peace, and we also have the right to have our own procurement rules, safety rules, and our own staff regulations. What's important is that we are not bound to European rules, and that's why it's so important. How many are we? We are now 25, the CERN family is 25 member states, plus 1 associate member states in the pre-stage to membership, and 9 associate member states, meaning that we have 35 countries, nationalities, different, that are going to participate in our call for tenders, and that's extremely important. The participation, that's the contributions, the CERN contributions, the CERN budget for 2025 was 1.3 billion, and Spain is the 5th contributor with a 6.6% contribution. We procure up to 613 million per year. As you can see, those are the procurements for over the last 20 years, 25 years, excuse me. And as you can see, we had a big peak for the construction of the LHC. We are having, again, a small peak right now, which is the Halloumi project that is going to be finalized, hopefully, in the coming years. And we are preparing ourselves for a long shutdown in June 2026. That is going to last for 4 years. And that, as you can see, has increased our procurement over the last. Just on an industrial return that's for Spain, I will say that I have good and bad news in this sense. The good news is that we are about to be well balanced, and that's a good news. The bad news is that we have a mechanism that advantages the companies that originates from a poorly balanced member state. I hope that in 2025, Spain will not be well balanced. Currently, we are at 0.97, so very, very close to the 1. And the calculation is also similar to the one that they have in ESO, is the percentage of the expenditure in this country divided by the percentage of the contribution of this country. You can see that also Spain is nearly well balanced for supplies, but also for services that we calculate separately. For services is over the top, which is just, I'm extremely proud of it. What do we buy? At CERN, we buy anything that you can imagine. Think of something, we buy it. We buy civil engineering, cooling and ventilation, electrical engineering, IT, mechanical engineering, electronics and radio frequency, cryogenics, vacuum, health and safety equipment, transport, handling, office supplies, and industrial services. What we call industrial services is contractors' personnel working on the CERN site on a permanent basis. Anything that you can imagine. We have, as I mentioned, we are right now on the upgrade of the LHC, which is the Hailumi project. Is going to be, we are going to install it soon. The next projects, one of them is the FCC, that Luis is going to mention it afterwards, so I'm going to go much faster. That's the proportion of the procurements in 2024. As you can see, a quarter of our budget, of our expenditure, is in civil engineering. We have about, 30% that goes for vacuum and low temperature, IT, mechanical engineering, and then the rest. We buy everything that you can imagine. But we also buy for the experiments. The CERN, basically what we procure, what CERN budget pays, is for the accelerator, the machine. But the institutes from all over the world are going to participate in different detectors. In ATLAS, ALICE, CMS, and LHCb. And for those experiments, we are also, in the procurement service, we are also going to procure whatever they need. How do we buy? We buy whatever is standard products or products that already exist and existing manufacturing techniques well known. We are going to buy it on a functional specification basis. However, most of the non-standard products are going to be bought on a build-to-print. And that's some of the questions that I have been receiving here over the last 2 days that I've been here. We have an engineering consultancy group. Are we going to buy to CERN? Well, CERN has the engineering services are in-house, most of them. And therefore, we are going to produce a specification, a build-to-print specification for the most technical requirements. Some of the rules. Of course, whenever we are going to send a technical specification, you will have to comply with the financial, technical, environmental, and delivery requirements. For us, the price is going to be extremely important, and I'm going to mention it afterwards. Most of our procurement is adjudicated on a lowest compliant basis. So the money is extremely important. The services, of course, are going to be on a best value for money, and some supplies, but not many. We also have an objective of achieving a balanced industrial return for certain member states. And that's why we have a specific rule that gives a second chance to the companies producing in what we call poorly balanced member states. We also have transparency and impartiality. Tenders are open to all member states, but there are going to be some conditions, and I'm going to explain them afterwards, and objectivity and equal treatment, of course. Some of the principles, we are going to select which are the bidders that are going to be invited to our call for tenders or invitation or price inquiries. How are we going to select it? I'm going to explain it afterwards. And we keep the confidentiality. Our openings are not public, and we do the evaluation of the bids private. As I say, most of the procurements are done on a lowest compliant bid, but there are also some of them which are adjudicated on a best value for money, and whenever you receive the documentation from us, the tendering package is clearly indicated on which is the basis that is going to be done. How do we procure? And that's what I realized for the last 2 days. Most of you are what I call small and medium firms. I will say that those are the ones that are extremely, in particular, if you haven't worked for CERN before, I will highly advise you to concentrate on what we call the price inquiries. Price inquiries are up to 400,000 Swiss francs. You are going to have a deadline for submission, which is between 4 and 6 weeks. And how do I'm going to learn about which are the future price inquiries, what is coming up? is going to be extremely easy. Whatever is above 50,000 Swiss francs, or ILOs, which are present in this room today, Manuel and Carlos, will receive every single price inquiry. They are the ones that know which are the ones, but you have to be selected to be able to answer to them. But the price inquiries that are above 200,000, they're going to be announced on our CERN website, and I'm going to show you how afterwards. For whatever future needs above 400,000, we are going to do a market survey. The market survey is going to be used for the selection of the firms that are going to be able to reply to the future call for tender. And therefore, a market survey will be announced also on our webpage. And if you are selected following the evaluation, qualification criteria that is going to be present in the market survey documents, then you will be invited to participate in the invitation to tender. We have what we call country of origin. For us, extremely important because we calculate this industrial return for whatever is supplies. How we consider country of origin is where the goods are manufactured or where the last major modification took place. For the services, where the bidder is established. And the services, I remind you, is the services that are performed on the CERN site. Thus, 100% has to be produced in member states. So we are going, yes, in principle, yes, except some specific products that we will clearly indicate it is on tendering process. If at least 60% comes from what we consider a poorly balanced member state, then you will have a second opportunity, a second chance to make a second bid in case the bid, your production comes from a poorly balanced member states and that the first one was coming from a well-balanced member states. We will ask the bidder coming from the poorly balanced member states to make a second offer. That's going to be for any contract above 100,000 Swiss francs. Last year, we did a survey on the type of companies that reply to for which we work with. 70% of the companies that work with us are SMEs. That's something that we are extremely proud. We have no policy concerning SMEs, but it's the type of production and of course, the amount of the contracts that, in average, that makes it that CERN is extremely attractive to an SME, as a small and medium-sized company like yours. Out of this survey that we contacted our suppliers for the last 2 years, we contacted more than 1,500 suppliers. 98% will recommend CERN as a client. Good. 25% hire new personnel thanks to working with CERN. 71% had a positive impact on their sales. 63% use us as a marketing reference. If you want, we allowed you to use the CERN logo, CERN supplier logo, if you request it, and that you are comply with certain criteria. 66% improved the products or services that they sold. 47% developed new products. 70% improved the technical knowledge in their field, and finally, 52% found open new markets. That's something that we found extremely positive, and we hope to motivate yourself to become also part of our CERN suppliers. We got also an excellent rating, so that's always good. Extremely important if you want to learn what's going to come. Everything is on our webpage. Our webpage is procurement.web.cern.ch. You will find which are the countries that are poorly and well-balanced member states. You will find under business opportunities, in the business opportunities, on the second one, you will find the shopping list of everything above 200,000 Swiss francs. And you will know exactly in which is the status. You will even find the documents for the market surveys. And in this information, you will also understand who is the person responsible. It's extremely important that as soon as you are interested in a market survey is going to be above 400,000 Swiss francs, that you contact the technical responsible and you learn exactly what's the next, what's going to come, exactly are you able to respond it, how you can best respond to it. The first thing I'm going to advise you is please, as Alain said before, register in our database. Registering the database, you are going to select what we call the procurement codes. The procurement codes is the families on which you are going to be interested in supplying to us. We are going to contact the companies for every single future needs. The companies that are poorly balanced, we contacted them systematically whenever they have registered under the specific procurement code. And then afterwards, you will receive the orders through the suppliers portal. You will find in our webpage also the contacts which are relevant for you. I will just mention two persons are extremely important, which is Manuel Moreno and Carlos Pérez Benítez. Carlos Pérez Benítez being located, working of course for CEDETI, but being located at CERN. They will be able to tell you exactly what's coming up, how to help you to find your way around CERN. If you need information about maybe completing an invitation to tender a market survey, they will be able to help you. And please follow us on LinkedIn, Business with CERN. We are posting new business opportunities on a weekly basis, and that's extremely interesting to learn how we progress. The upcoming tenders at CERN, I won't have the time to go through all of them. We currently have more than 100, but I'm just going to present in a very short slides what we have. As I mentioned, we are going to have needs on cooling and ventilation cryogenic tenders. We always provide a range and the planning and the technical responsible who is responsible for it. We are going to have also electrical engineering, magnets, tenders, mechanical engineering, raw material. I have seen that some of you are extremely interested by this category. Those are ongoing market surveys. When we say market survey has been published, it means that it's already on our webpage. The documents, you can fill them in at any moment. And there is only one thing. You may find out that in the letter, it says that the date for reply has already passed. It doesn't matter. What is important, if it's still published, what's important, meaning that you can still reply to it. Do not hesitate, reply as much as possible, and decline if you are not interested and you have been invited, of course. We also have IT tenders, construction on-site and off-site services. The head of department of those is present here today. And then I think is the end. I was going to go in detail to all of them, but I'm afraid that's...
Thank you, Cristina. If you download the slides from Cristina, you will see that the tables that she showed right now, there is much more information for each of the tenders, so it's very valuable information for you to consult. And I also want to highlight what Cristina said. We have 2 ILOs, and we have the luck of having one ILO in CERN, Carlos, who is over there. So he can help you to find the key persons in CERN to discuss about technical issues regarding the procurements or the market surveys or the smaller ones. I was going to ask you, Cristina, for the tips for a new company, but I think that mostly you said them. I don't know if you want to add anything.
Maybe I want to make a kind of not forget to-do list. The first thing will be register yourself in the database. That's extremely important. Or find out if your data is updated. Second, follow us in LinkedIn, follow us on the webpage, see what is necessary. It may be that there is nothing going to be published for you. Therefore, you will have to find a way around CERN, and that's what is extremely difficult. For this, Carlos is the right person that can tell you exactly which section which group may be interested looking for something that you may be selling. Contact the technical person that is going to be responsible in this area. See what are their needs, how you can, maybe they don't have immediate needs, maybe they're going to have needs in the future. Try to find them out. If you see something on the web page that interests you, the best thing will be that you contact the technical responsible, again, as soon as possible. If you receive a tender or you've been invited for a price inquiry or a call for tender, do not hesitate to ask as many questions as possible. The important thing is that you make the right price from the beginning. It's the lowest compliant price that gets it. And many years ago, there was a Spanish company that came to me and said, I finally got a contract for CERN. It took me 10 years to get it, and I understood it. I say, okay, tell me what's the trick. I will just explain it to everyone. There is only one simple trick, to understand what's the technical requirements, to really reply and give a price to what is requested. Don't try to give a price for something that is not requested, but it's going to be more expensive or it's going to be not compliant. So afterwards, you can put as an alternative, you can put it. If you have never worked with CERN, I will advise you also to, in our webpage, we have the suppliers database, and you know exactly who is already supplying to CERN or not. If you see somebody that you can be complementary, it's also good that you contact this company, either Spanish or not Spanish, doesn't matter, and that you join them and see how can we maybe collaborate in future contracts? That's also extremely important. It may be that you don't have a direct contract with CERN, but you may start being a subcontractor at the beginning. That's something, another way to understand how to work in Geneva, in France. It's not easy, and it's important to know it.
Thank you, Cristina. Lots of information and very useful. So I hope it's been useful for you too. So let's go on with our next speaker, also from CERN. We have Luis Miralles. Luis Miralles has developed his professional career on the fields of robotics, automotive, high-energy physics detectors, and particle accelerators, and always on research and development tasks. He has been part of the teams of IDIADA here in Spain, IFAE as well, CELS, ALBA, and CERN, of course. From 2003 to 2013, he served as engineering division head at CELS, ALBA. From 2013 to 2020, he has served as General Infrastructure Services Department head at CERN, and now he is the project manager in charge of the CERN contribution to the US Dune experiment. So Luis is going to give us two talks. The first one is going to be about the FCC, so a more view of the future, but we have to start getting ready, of course. The second one is going to be about what I just mentioned, the contribution to Dune. So he has a bit more time, of course. Thank you, Luis. We're very happy to have you.
Okay, thank you very much to all of you for being present. Thank you very much to the organization for the opportunity to give a grasp of CERN activities. As Javier said, today I'm going to give 2 points, one on the future, the FCC project, and another one on the present. So going for the future. So we are talking about FCC. So this is a project that it's the next flagship project of CERN. We are talking of a collider of about 90 kilometers to be installed between France and Switzerland, nearby the Lake Léman, Genève, depending on the nationality, basin. And I will try to tell you at this moment, entertain you at this moment, where we are with this project. So the first thing is the first important part is that the viability study, feasibility study, has been published in March, had 3 volumes, but it means that consider the 3. Sorry, I don't know what I did. Okay. Fine. This is sensible. So it considers the 3 main vectors of a projects, in this case, physics, experiments and detectors, the scientific part, the implementation from the technical point of view, I mean accelerators, technical infrastructures and safety, and then the implementation from the physical point of view, from the geographical point of view, civil engineering, implementation and sustainability. So this feasibility study is an input for the European strategy exercise that is going on at CERN now, and that is being just concluded, and it will be submitted in March for the consideration of CERN Council. So what is this collider? Okay, so this collider has, this project has an approach using the same infrastructure, so the same civil engineering infrastructure. A first phase that is an electron-positron collider, that is a Higgs factory, is focused on the study of the Higgs physics. And then in a second stage, this could evolve, or it is designed to be evolved to a hadron collider that it will be working at the energy frontier. So the first step is a precision machine. The second step is a discovery machine. Okay? So, as I said, it's sharing the civil engineering and most of the infrastructures. Timeline, long. Okay? Well, long. Is the typical timeline for CERN, but it's long for other aspects of the life. So we are talking about this feasibility study that has been finalized in 2025. It will be submitted for CERN consideration probably, most probably, as part of the European strategy exercise with an eventual approval by 2028, and after 5 years of preparation, starting on 2023. As a milestone, what is as per today, the plans is that the High Lumi LHC will be ending his mandate, let's put it like this, in 2041, and then operation of the first phase, that is the electron-positron collider 2048, up to 2075. As you see, we are talking about a project with a lifetime from the first, well, and we are not accounting here for the previous works, but just from now, we are talking about 50 years project. Okay, so all this is, in addition, if you think that is long, in addition, is ambitious. Okay, so when we take into account what are the past experience of CERN, so the approval timeline of the different strategical points, and then the constraints on the financing model. And it's also assuming that after the approval of CERN, we have the financial and human resources in order to start immediately the design and to put the blueprints ready for purchasing to start to launch the process. So it's ambitious. It's long, but it's ambitious. Okay? Now, more funny. So the first step is to see if it can be done geologically. Okay? So from the point of view of the implantation. So here, more than 100 variants have been studied in order to looking for the different geological constraints, looking for the surface constraints. Of course, you need also in facilities on the surface. It could happen that you have a village and you cannot end up in the middle of the main square of the village. So seriously now, we are talking about considering geology, surface constraints, environment, infrastructures, how to bring the electricity there, how to bring the services there, and of course, at the end of the day, this is an accelerator. What it matters is that it works, so the machine performance, okay? So we cannot do n'importe quoi with the geometry and with the lattice of the machine, okay? So there is already, we end up with this 90.7 option, ring, 4-fold, and with 8 surface, okay? The good news about this is that we have not found out any showstopper, okay, at this moment. Okay, so the initial state of the analysis is that from all points of view is feasible. That is the objective of a feasibility study. Okay, so the environmental part that is a must in our days was one of the points that was more carefully evaluated because the impact that will have in the region and in the population around the facility. All this with a lot of simulation, but not only simulation, with a lot of real measurement. So we have developed a full geological map, 3D map of the underground conditions in the basin area. Okay, so we are talking of about excavation of 625 million cubic meters, that once we will bring this on the surface will become 8.5 million, okay, because underground they are compressed. When we bring it out, they decompress, and then it takes much more. So an enormous work has been done in collaboration with Vienna University, Technical University, I don't want to make a mistake there, in order to find a way to recycle this material to be used in civil engineering and in other applications, okay? So that is not just waste, spoil, okay? So this is also part of the preparatory works. Again, the good news there is that we found a racetrack, let's put it this way, that minimizes the risk inherent to the underground excavation of a tunnel of those dimensions that it's going in between different type of materials, okay? So the most dangerous part is when you pass from one type of geological material to another type of geological material. Here we are doing this transition twice. So we go for the glacial moraine of the basin to the molasse, that is a particular type of material in this region, and then we go from the molasse to the limestone, that is the Jura Mountains type of geological configuration. So this is where more of the detail in the studies has been placed. Okay, more than 80 kilometers of seismic investigations has completed. You don't see it very much, but this is basically a track that is vibrating the ground in order to find out what is below. And then there are also bores that has been made, most interesting ones, and that give a lot of expectation in Geneva, is to make bores in the Geneva Lake. Okay, so they are very sensible about going beyond the lake in the Geneva region. So again, the good news is that we didn't find anything that tells us that this is not normal works in tunneling in Switzerland. Okay. In the meantime, of course, we have various programs of research and development from the different technologies. We are talking about radio frequency, how to produce it, about radiation absorbers in the vacuum, newer technologies with 3D printed metallic components, alignment, magnets, okay, almost everything that may be a showstopper or not, or should be able to demonstrate that from the technological point of view is feasible. Okay, this is RDE, so this is a lab. There is a big step from here to here, from the lab to the industry, okay, and this step is what is going to come when we are going to do prototyping. Okay, so we did, of course, with the magnets. So this is the core of a collider, and here we have collaborations with ENFN, with PSI, and also with CMAT that has been part of those collaborations in research and development from the very beginning. Okay, another aspect that we are developing, because it's, as you can imagine, the energy needs for this type of machine are gigantic. So everything that you can save in this direction is important. So the development of high temperature superconducting materials, not only for the transport of the electricity, but also for the construction of the components themselves. And in this case, we have also collaborations with almost all the member states, where we have institutes like the KIT, the Karlsruhe Institute of Technology, PSI, or CIA in France. Numbers, okay? Then we are talking about, for the first phase, that is for the precision machine, an electron-positron collider of 15.3 million Swiss francs. Okay, so here you see the breakdown. So is about half of it is the civil engineering, and the other half of it is the technical infrastructures and the machine itself. So The experiments, there is a very little contribution from CERN because the typical scheme of CERN for the experiments are external contributions, and CERN contributes typically with between 10–15% of it, and the additional costs, you will see it there, is 1.3. There we are assuming here about a 20% contribution of CERN for the experiments, about it. Okay, so altogether is this 15,000 millions of Swiss francs. It's a global collaboration. So independently, so we have the main weight coming from the member states of CERN, but we have collaborations everywhere and in the world, and this is a common effort. So this is a very big machine. It's an enterprise, I would say, for the world. It's not just an enterprise for CERN. Okay, so and if it's not global, it will be very complicated to make it work. Okay, so we are leading there, but we need the help of everybody in order to make it work. Financing. Okay, so the big question. Okay, you have the numbers, you know how it costs, you say that this is going to be possible. Then how and who is going to pay for it? Big question that I don't have the answer, but I can give some hints. Okay, so from non-member states, we have a letter of intentions from the United States and Canada. United States is from April 24, and from Canada is April 25, relatively recent. We have a very strong support from the European Union. Okay, so just not only by statements, but also by the intention to introduce in the next round of budget setup for the European Union with a line of 3,000 million euros for this particular project that is very highly ranked in the strategic projects of the European Union. So there is a political statement telling that even CERN is an international organization, as we have learned, is not part of the European Union system, but has a strongly support of the European Union system, and the European Union is an observer member of CERN. In-kind contributions. So the system for CERN projects is mixed. Okay, so it's hybrid. Now hybrid is a very popular sentence. So we have on one side the typical purchasing system, competitive tendering, and then we have the in-kind contributions. Okay, so the in-kind contributions is where let's say, the local instruments of the countries can help the industry to prepare themselves in order to contribute and also to assume some responsibilities by those member states for those contributions. Okay, so it could include material deliveries, it could be include development. Okay, so needs still to be write down what are going to be the exact rules and regulations of those in-kind contributions, but something that is very important is what it's just in bold at the bottom is the FCC procurement book. So this is being prepared, and this will be the Bible on how to contribute or how to compete for the contracts of this project. Potential in different aspects. So this is potential in-kind contributions in the field of magnets. We'll not go through each one of the lines. Booster, collider, quadrupoles, sextupoles. We are talking about a total amount of about 700 millions. Okay? I think in the next slides, what is important is to read the first point, because this may help to see strategically in which direction to go, okay? Where it's more interesting according to capabilities, according to competencies, according to synergies, on which aspects to decide to bid and bet for the two things, okay? So magnets, one of them, radio frequency system, of course, including everything, raw material, production, testing, and then, of course, all the part for the very special 800 megahertz. This is an option, is additional 2,000 million, this option, but has a high probability to end up inside of the menu. Okay? The vacuum system, again, 420 millions. So the first analysis or the first approach in preparing this, say, purchase book is that about 1,400 millions of Swiss francs should be pruned to be part of in-kind contribution by the different institutions participating in the collaboration. Okay? So there is place there. So main conclusions, the viability study has demonstrated that the project is viable from the scientific point of view, from the technical point of view, and from the implantation in the territory point of view. There are not showstoppers. Now it's just a question to make a decision, okay? So then, in this framework, so the FCC will have a very wide scope of opportunities to participate via competitive tendering on the framework that Christina has just explained, or via in-kind contributions. That is a typical also mechanism in CERN collaborations in CERN projects. For CERN, beyond the very nice sentence that you always get from the Council, and that we highly appreciate, but the most important one is that the Council states that the feasibility study is the basis for the strategies of CERN, and the FCC studies shall continue. Okay? So this is extremely important, and that the funding scenario is something that needs to be worked out, but at least what we already know that I have just explained in the slide before tells us that we can continue because there is hope that this at the end will work out from the funding point of view. And with this, I stop about the future, and I think that I will go to the present.
Yeah. Okay. Do you want to go on with the next presentation now?
Yeah.
Okay.
And then,
okay.
Because I think that it's the overall view,
okay.
What is important. Okay. In the previous presentation, I was talking on behalf of the CERN FCC effort. Here, I'm talking on my own behalf, okay? So here, if you ask here, I'm responsible for the good and for the bad, for both things, okay? So introduction a little bit on the design, and then where we are with this project, okay? So we are talking about, is the first international collaboration project in the United States. So we are talking, I don't know if this works, yes. This works, but you cannot see it. So we are talking about producing a beam of neutrinos in Fermilab, nearby Chicago, in Batavia, and then sending this beam of neutrinos across the crust of the Earth up to a detector facility in Sanford Underground Research Facility. This is in South Dakota, and is 1,300 kilometers apart. Okay, so this is the typical CERN or experimental setup. You know what you are sending from one place, and you detect what is arriving, and you try to figure out what happened in between, okay? So this is the rough idea about this. So what CERN is involved? So CERN is involved because we have a collaboration, international collaboration agreement between the United States Department of Energy and CERN, and under this agreement, CERN agreed to provide part of the detectors, some parts of the detectors, but mainly the two big cryostats where the detectors will be hosted. Okay? So that's the scope of the CERN contribution. What we are talking about, okay? So what is the use of this? So this is a TPC, so this is a time projection chamber. So you have a fiducial mass, in this case is liquid argon, that is inside an electric field. Okay, when a particle interacts with the fiducial mass, produces charged particles, and due to the electrical field, So those particles end up in the anodes, and then the anodes are constructed by wires, and you know in which wire the charge has been deposited, and if you measure the time that takes the signal to arrive to one end with respect to the other end, you know also at which point of the wire. So with this, you have a 2D projection of the trace of the particles, okay? But we are looking for a 3D, okay? Then what is interesting in this type of instruments is that at the same time that you produce the charged particle, you produce a photon, okay? And the speed of the photon is the speed of the light in the liquid argon, but the speed of the particle, of the charged particle, is fixed and known. It depends on the purity of the liquid argon, mainly. Okay? So in such a way that if you have a photomultiplier, you detect the photon, and you say, oops, a particle is going to arrive, and then you wait for the particle to arrive, and you measure this time, is the time that has arrived, and then as you know the speed and you know the time, you know the position. So then you have a 3D trace of the particle, okay? So at the end, here you get a 3D picture of the trajectory of the particle. And that's all the physics I'm going to talk about it. And even I think it was a little bit too much. Okay, doesn't matter. How it looks like. So this is big. Okay? So you see the scale, you see the two persons at the bottom. We are talking each one of the detectors, each one of the cryostats is about 68 meters long by 17 meters wide and 18 meters high. And the overall weight detector, fiducial mass, and cryostat itself is about 20 kilotons, 20,000 tons each. Okay? This is going to be installed in a former gold mine in South Dakota, 1.5 kilometers underground. The civil engineering has been completed. This is already there, and this is where those two cryostats will be installed. Okay? As I said, how it looks like, as I said, 65 meters long by 17 by 18, and a total weight instrumentation plus liquid argon plus cryostat infrastructure of 20,000 tons. Okay? As I said, two of them. Main components. So the main component is an external structure, is a steel structure, welded mainly. And then that is what you see in green, and what you see in blue is the tertiary membrane. So this is the tertiary containment system. Okay? So inside this containment system, you have the isolation that allows to control the temperature that inside the cryostat is 40 Kelvin, and outside the cryostat you have 25. So you go from 40 to 293. So this is the gap. Okay? How you do this? So this is a technology that has been developed by CERN. So it's a technology that it's based in the technology used for the liquefied natural gas tanker transports. Okay? And CERN, in collaboration with the owner of this technology, we have developed the particularities in such a way that can be used for cryostats for scientific applications. So what you see in the bottom is how it looks from inside. Okay, so we have two of those prototypes at CERN, and the full trick of this technology is this that you see here. Okay, so this crossing of this allows to go from 293 to 40 without the membrane to move. Okay, so the contraction is absorbed locally. Then you don't have the problem of the ends, the corners, to be movable. Okay, so this is the full trick. Well, there is more, but this is the main point. Okay, look where we are with this. So at this moment, the cryostat warm structure was, and the second, for the cryostat 1 and 2 has already been delivered to Rapid City. Altogether, we are talking about 70 7,000 tons of steel. We have delivered also the fasteners, the clamps is already there, and we are delivering the cold structure material. What you see in the photos is part of the metallic structure, of the worm structure in Coruña, in Spain, and we'll tell a little bit more where all this has been produced. And then on the right is the acceptance of the cold structure in China and in Korea. Okay, so this is, at this moment, is being delivered. We expect to have all the material, about 8,000 tons of material in Rapid City by middle January. Procurement, tendering status. As you see, green, and this could not be green without the help of the teams of Cristina. Okay, so you can, well, I will not tell how hard it is to get there, but from this point of view, so, and I will go a little bit through it in order to give an idea where all this is come. So the procurement of the worm structure materials, all the 7,000 tons of steel was coming from Luxembourg. Why? Because it's the only place that this is produced in the world. Okay, and this is an exception for the rules at CERN. So if it's in a place that is not a member state, but it's the only place, you buy it there. Okay, so this was the case here. The manufacture of the worm structure components and the worm structure membrane, this was produced in Spain. Okay, and this is coming from a full, competitive, low, technical, compliant tendering. Okay, so the procurement of the small components, the bolts, the clamps that are making the joints between the steel structure and the membrane was coming from Spain. And again, these two contracts were a full competitive tendering, lowest compliant. One in the Basque Country, the other one in Valladolid. The transport of the two structures, the companies providing the services, origin, Spain. And again, full competitive tendering. The procurement of the cold structure materials, that is a service, because it's not the origin is China and Korea, but the procurement is managed by a Spanish company that also got it in competitive tendering. Okay, and what is left is the underground assembly of the cold structure that I cannot tell who is going to get it, but we don't have still a date. So this is an estimation. We don't still have a date on when we are going to launch the tendering. So the message here and the numbers that I'm talking about, we were talking about more than 60 million euros that this project has spent in Spain via competitive tendering. So the Spanish industry can compete successfully in projects at CERN. Okay? Now, as I've been talking a lot, and I showed a lot of slides, I think some images may help, and I think if it works. this. Thank you very much for your attention.
Thank you, Luis. Thanks. Super interesting. And it was nice to see the future. And the future comes from the present, and especially to see the success of the Spanish companies in so many contracts. I'm very pleased to see that. And I hope that we will see that in some years to come also. I wanted to ask you, Luis, in the first presentation for the FCC, we saw that there is this feasibility study and all the work that is going on to try to find the funding and so on. And you said the construction would start more or less in 2033. So I think that for science, these are normal times, but for industry, it's like ages away. You know, so many things can happen. So what message should we give here? We always say that industry has to get ready. They have to invest in R&D. Could you elaborate here and help in the message?
Yes, general statement, but yeah. So look, we are going to start in 2033, but we are going to start in, well, hopefully we are going to start in 2023 with the civil engineering. But all the research and development is not still there. So there is a long way to go also for CERN, to go from the lab, as I said before, to the industry, to the mass production, and this goes to prototyping, research and development, and this will happen well beyond 2023. Okay? So is all these processes, all these programs, all these collaborations through CIEMAT, through other different institutions, so the competitive tendering that is going to be put in place by CERN itself, but not only, but also by the institutions that are collaborating with CERN in order to prototype, in order to transfer the knowledge to the industry, is there. Where is it strategical? Is strategically to be present in order to learn, in order to be prepared when the mass production will come. So is basic. So we have very long timings, and you need to adapt to these timings. We know that the industry is there to make profit for the stakeholders. We may provide a system, we may provide some funding through the prototyping and research and development programs for the industry to get prepared, because if the industry is not prepared, this 2033 is not going to happen.
Mm-hmm. Yeah.
So is capital to be part of the research and development programs of this project and the prototyping.
Thank you, Luis. Okay, let's go on. Now we have our next speaker. Here we have Mario. So Mario Martínez is an ICREA research professor at the Institut de Física de Altas Energías in Barcelona, renowned for his contributions to experimental particle physics and gravitational wave research. He is a member of the Virgo Collaboration and the Einstein Telescope Organization Directorate, contributing to the development of this next generation gravitational wave observatory. And Mario is also the coordinator of the ET preparatory phase project, which is currently in its last stages. It ends this year. It is a project which is preparing the road for the construction, the approval, construction, and operation of the future Einstein telescope. So Mario, I'm very happy to have you here.
Thanks a lot. Thanks for the invitation. Thanks for the opportunity. Thanks for the presence of the industry. Well, the mission of this talk is to give you the feeling of how complex the thing is, how attractive it is, and give you a feeling of the timelines, and again, the message is that you need to get prepared. Okay, so but let me go into this. So first of all, I felt that I need to say 3 words about what a gravitational wave is. And basically, can be said in 3 words. Basically, Einstein theory tells you that mass and space-time are talking. So essentially, mass is able to curve the space, and the curvature of a space is able to dictate the energy momentum densities, if you wish. So this is basically Einstein's general relativity. Now, if you start perturbing the masses, you generate perturbations in the space-time. Those perturbations propagate with the speed of light. These are gravitational waves. It's simple as that. It's like dropping a stone in a lake, and you have the waves. Now it's not the waves of the water. It's really a space-time propagating perturbation through time. Okay? Now, I am generating gravitational waves, but you will never be able to measure it. You need to go into very big things, like neutron stars, like black holes, like supernova, and like, for example, pulsars. Now, one thing that is there, but is very close to the heart of any particle physicist, is that gravitational waves can go access to almost the Big Bang, because it's not that the universe gets transparent. No, the gravitational wave passes through. So it's also something very, very close to particle physics, because we'll go closer and closer to the Big Bang. Anyway, that's gravitational waves. Now, this gravitational wave has been detected. First detection happened looking at the merging of two black holes. Was done by the existing detectors, which is LIGO, two LIGOs in US, and one in Europe, Virgo, and one on the ground, with Skagerrak. So what you see is something similar to what you see there. So two objects that are essentially orbiting, they merge, and then there's a single object, a bigger black hole, and then the thing stops. So these waves we have seen. But essentially, the height of the wave is 10 to the minus 21. Okay, and this actually, this is why these three fellows there got the Nobel Prize in 2017. Now, 10 to the minus 21 is the same thing as saying that I'm coming with a ruler and I'm going to measure the distance between here and the sun with the precision of an atom. Of course, you don't do that. You don't take a ruler. What you do laser interferometry. That's what we do, because with a ruler it's impossible. With photons, it's possible to measure these kind of things. The first message is that this is the kind of precision we have. 10 to the minus 21 means everything matters, and everything that has to do with industry is going to be very demanding, but it's an opportunity as well. Okay, so this is the Einstein telescope. The Einstein telescope is a gravitational wave detector, laser interferometry, with an arm which is about 10 to 15 kilometers. Okay? It's going to map the whole universe. And what you need to do that is to go underground, to go into very high vacuum, cryogenic, lasers, high precision mechanics, low noise controllers, high quality optoelectromechanics, and also innovative adaptive optics, innovative infrared detection. And when I say that we map the whole universe, is because if you look at how far we are going to go, we are going to come so close to the beginning of the universe that we are going to go to the place where there were no stars, so the dark age. And if we start finding black holes, means that they are primordial, means they were generated by some fluctuations. Anyway, this means mapping the whole universe, basically. Okay, so the thing is that this is the sensitivity. I was talking 10 to the minus 21. We go actually lower than that. As a function of the frequency of the waves, the bottom line is that we want to go very, very low in frequency, and that's why we need to go underground, we need to go cryogenic, and so on and so forth, okay? So then we're going to do the following. This is the typical interferometers, where basically you have optical cavities. We are going to have one at room temperature, a lot of power in the lasers, very big mirrors, 200 kilogram mirrors, a lot of power, 10 room temperature, and then we are going to have the version which is cryogenic, meaning the mirrors are going to be cooled down to about 10 Kelvin, less power. One allowed us to go very low frequency, the other one allowed us to do the best we can do at very high frequency. And the combination of them is what actually buys the thing. Now, this is the more close to the reality. In fact, what we do is we are going to nest 6 interferometers in one site. At least this is the baseline right now. which means that you don't do 2 interferometers. You do multiply this by 3, if you wish, okay? With an almost 10 kilometers arm, as it is right now. Okay, and then collaboration is big. It's about 2,000 people. It's becoming at the size of a typical LSE experiment, which is about this. Spain is about 8% of the collaborators, so this is the size of Spain, which is the 3rd one in the list of collaborators. That gives you the feeling of the interest in the country for this. Then, okay, we are so worried about so big it is that we are cloning CERN organization into ET organization. So we will have a ET organization, and then we are going to have a collaboration, and so on. So basically, this is the first message. We will, sooner or later, we will convert so close to CERN organization that will be very, very similar. Okay, so where we are. So I show you here the timelines, okay? The timelines are the following. We managed to get into the S3 roadmap. Spain was one of the 5 countries that allowed for this to happen because supported the candidature. That's another message. Now, we were, at the time of S3 presentation, meaning 2021, we thought we could be able to decide the site this year, or maybe, well, it's not going to happen, but yeah, we are not going to be so far from that. And we were estimating a cost about 2 billion, American billion, 2,000 million, okay? Now, right now, we have, in the situation where we have 3 potential sites formally coming forward to say, I would like to build it, 3 of them. One in the, what we call Limburg area, so it's in the border between Netherlands, Belgium, and Deutschland. Now, this is promoted by NICEF. NICEF is the big lab in the Dutch. And they secure about 1 billion for construction. They have more money for R&D and so on, but they secure that for construction. There is another in Sardinia, which is promoted by NFN, and you can imagine they secure right now 1.3 billion. And Lusatia is the last one that came into the play. They didn't secure this amount of money yet, but they can have with a lot of energy. So now we have 3 sites. The 3 sites are really now furiously working to understand what is the best site. You need to go on the ground, see the noise, see everything. Meaning in terms of site characterization, whether we can build this infrastructure there, noise evaluation, geology, hydrology, costing, socioeconomic impact, sustainability, all of things that also was said before for the FCC are actually happening for the Einstein telescope. Now, there's another thing which happened, which is a little bit of a perturbation in the path, which is now ET is thinking about not building a triangle of 10 kilometers, but building eventually 2 Ls of 15 kilometers, longer distributed in 2 sites. This is something that we need to compare, is work in progress. Now, it's unfortunate that the most important thing is over there, but I tell you what it is. The site characterization of the 3 sites will finish by the end of next year. And the Proto Council of ET, which means a board of governance representatives, they established that they want to be in the position to select the site by the end of 2027. That's the times for you. So it's not in 30 years from now, it's in 2 years from now, okay? So this is the work just to show you how furious the work is done in the sites. And as I told you, basically everything will be ready by the end of 2026. And we have already now a panel that is deciding the criteria to decide. Because, of course, it will be a difficult decision to make. So we need to have an independent panel that decides the role of the play, okay? So industrial opportunities. For first thing, I short by money, okay? So civil engineering, okay, let me go back, if I may, for a moment. Here you see a pipe where how this is divided in civil engineering, vacuum, and so on. And I will follow this, basically, in the following slides. Essentially, civil engineering is essentially half of it. Then you have 1/3 is vacuum system and cryogenics, and the rest is installations and the detectors themselves, what we call detectors themselves, okay? So industrial opportunities in terms of civil engineering, technical infrastructure and services is essentially one half of the cost is 1 billion. Now, the industrial opportunities, I think, are comparable to those that we just heard about, comparable to those that we had at the time of construction of LEP, at the time of the LSC, or at the time of FCC. We are collaborating very closely with CERN, was evident in this meeting, for all the relevant aspects, not only civil engineering, all the relevant aspects. And we have an agreement with NFN, NIGEF, and IFI. We kind of agree with CERN that they will help us. They will help us on the infrastructures to need the operation interferometer, civil engineering, technical infrastructure, everything. Also, the vacuum system, the cryogenics, clean rooms, surveys, but also all the rest of how you run the on-site responsibilities on logistics, handling, transports, and so on and so forth. We do have already a layout of the tunnel. We do have already a layout of the caverns, okay? As I said, we basically have very frequent visits to CERN because everything that happens at CERN is the right model that should happen in ET. That should be clear for everybody. And we are basically trying to understand the size of the complexity of things like the vacuum and vacuum services rooms and so on and so forth, okay? One of the points which is unique in ET is that we need to be very clean. So everything comes with a clean room, everything, okay? It's not so much in the colliders, but here, cleanness is a key, okay? So that's where I'm going. So we have, you heard this meeting about the ET vacuum pipes at CERN prototype. This is something that CERN took the responsibility to help us in making the prototypes. There are opportunities there to be in the construction of the second prototypes to come, okay? You see here a picture of the ET Pathfinder of NIGEF. I mean, in Maastricht, but it's actually under NIGEF. But are the big numbers you want to know are those numbers. We are going to be about 120 kilometers of 1 meter diameter tubes with about 3,000 deflecting baffles. We are going to have vacuum pumps every 250 meters. We are going to have about 300 vacuum towers to suspend all the optics. We are going to have cryotraps in the entrance of the main optic towers. We are going to have mirrors cooled, as I told you, to take Kelvin, some of them. So we need cryo-shieldings. The experiment will have to run under very, very tight, ultra-high vacuum conditions at the level of 10 to the minus 10, or even 10 to the minus 11. And then we have very strict optical requirements. Everything matters if you want to go in 10 to the minus 21. Matters the mechanics, matters how you treat the surfaces to limit the outgassing, matters the high-quality polishing, matters coatings for infrared detection, and so on and so forth. Everything matters, and there are a lot of opportunities here. Then optics, mechanics, control systems, DAQ is one-third of the cone. So here we are talking about very high-power, ultra-stable laser systems. It's continuous, ultra-stable laser systems, and all what comes together with that. All what comes with very precise interferometry, all what comes with optical component material, including mirrors, coatings, optical sensing, but also seismic isolation, suspensions, cryogenics, all of this. Basically, we are now at the point where we need to launch this R&D, organized R&D, to do the prototypes and so on. And this really is the moment now to get engaged, basically. And I showed you some pictures about the kind of things that, what that really means. I mean, the complexity is obvious from here, okay? Okay, and then there are other things like control systems, like environmental monitoring, network seismometers, microphones, magnometers, Combs ray detections, and then the whole field of data analysis and computing. We need supercomputer centers. They have been used right now. We need all of this, basically, noise huntings, all of this, and sensing, sensors, silicon sensors, germanium sensors, in-gas sensors. Everything, basically, is there, okay? Okay, so we need to do the R&D of all of it, most of it. And there are a lot of R&D platforms coming along with money injected from the countries, mostly from the countries that they hope to host, but not only. Also, we are going to be there as well. And for example, I show you the Maastricht setup where they try to go into cryogenic mirrors. The same thing happens in Rome. There are a lot of R&D on better active mitigation of Newtonian noise, means seismic noise. A lot of R&D on infrared detection. A lot of R&D on making these 200 kilograms mirrors. A lot of R&D of new coatings. All of this is there, basically. And that's what it is. Now, contacts. Of course, you can contact me. There they are. But you can go into the Einstein Telescope webpage. You can go into the preparatory phase. By construction, every document in the preparatory phase is public. If you don't find it, you ask me. But the principle is public, and there are relevant things there, like proto-DDRs, like things that really you would like to see. And then there are latest symposium, which of course is also public. And there are 3 workshops coming up related with industry. One on vacuum and cryogenic at CERN in April, one on sustainability infrastructure in Rome in February next year, and one in industry for computing in Amsterdam in April next year. Stay tuned. You need info, you ask me, and I give you the info. That's it.
Thank you, Mario. Really, very complete information that you gave us about the project. I think there are enormous opportunities and they are not so far away. So here we really have to work hard to try to invest. As you said, the host countries are putting in a lot of money and we don't have so many resources, but we have some tools, and I think that industry that can play a role have to use them to get ready and to invest in their R&D and to get the knowledge. So I wanted to ask you one thing, Mario. Let's see how I can explain it. We listened to Alain and Cristina. Both of ESO and CERN are IGOs, international governmental organizations. This gives them the freedom to procure with their own rules and much more flexibility. Of course, it's much more complex. Next, we will have Mirko. Mirko comes from ESS, which is an ERIC, which is a different kind of scheme, a European scheme for RIs, which has to follow European public procurement rules in a way. So they're a little bit more constricted. And I know that in the ET, this decision has to be taken, what the ET is going to be. Okay. So I guess, correct me if I'm wrong, so I guess that this will also impact how industry is contracted, because you might also want to decide to set some fair work return rules, which probably will depend on what each country will contribute financially, which is different from CERN and from ESO, because I guess that in CERN and ESO, procurement is open, and it doesn't have to do with how much, well, in CERN you have these realignment rules, but not so strict, I would say. So what can you tell us about this, Mario? Okay. What is your feeling?
My feeling? First, let me say, of course, this is in principle part of the preparatory phase. So part of the documentation I was pointing to, also there is a full work package on industrial returns, which one of the conveners was here in this meeting, by the way. So that's to say that something, but clearly the model depends on the model of governance that we are going to give to ourselves. Now, I can tell you that we recently submitted to a panel of very serious people, including the head of financials of CERN, a first document of possible financial models from ETPP. That's something that, of course, has to be discussed by the ET Proto Council, no doubt. And as I said, depends on also the geometry, if it's a single place or it's a distributed place. What I can tell you that right now, what I see is we are considering an ERIC, or we are considering a model which is similar to an international organization, meaning CERN-like or ESO-like. Okay? That's one thing. Certainly, there are a lot of voices trying to convince everybody, including myself, to say CERN model, international organization with all this freedom not to be bounded is a very good model, but certainly it's not up to me to decide. It's a very convoluted decision that has to do with the countries. Now, certainly you can expect that If we decide to build in a place, the country will put a lot of money on the civil engineering. That's sure we are going to do. Probably we will have to ask to pay for almost the full thing of the civil engineering. But the rest really will be open to what we are going to do. For example, all the vacuum part, which is 1/3 of the cost, or the whole half of the cost, which is not civil engineering, will be open to discussion. Let's see what it is. Let's see what the country wants to do. The country itself, how much wants to invest. But a model following what happens at CERN will tell you that if you are at the level of few percent of the collaboration, that's why I show you the collaboration size. You would expect, hopefully, that you get order of magnitude this. So let's say 5 to 10% of the value of the half of the cost, whatever that is, it means, so a few hundred millions, maybe. But this something is very premature. Now we are working on that. There is a continuation of preparatory phase for 2 years, where we are going to have an intermediate legal entity, probably, and then we're going to the legal entity. So probably we will not know the legal entity in 2 years from now. But I told you where we are going, either one with Eric or with international organization. The voices to go into an international organization also is because we don't want to stay in Europe only. We want to allow the door to be open for US and for other countries that if they see a fully European organization, they might think twice. Okay, that's the same message that's CERN. As I told you at the beginning, we are basically very much targeting something particular. I don't know whether this answers your question.
Yeah, I think so. But in any case, I think that in our country, we have to demonstrate that we have capabilities to be able then to access certain work packages, or depending on these negotiations, how they take part. So this is important.
Let me say one thing more. There are places where we only have one possible person, candidate, institution that knows how to do this. So only one. So it's not that you have 10 of them and you all enter into something where there is a lot of friction. No, we really need to build those competences more than what we have. So there is wide open for someone that really, for example, the baffles in the prototype at CERN is already built by one Spanish company. And they know they learn a lot by doing that. Look easy, it was not easy. The coatings is something that we know 2-3 places in the world that we can ask for this. The material, polished material, 1 or 2 places. So R&D there would open the market to the Spanish institution. So it's not that really you enter into a field where there are 20 companies knowing how to do it. No, it's probably you have one and you need to really open up and invest a little bit to qualify yourself.
Okay, thank you, Mario. Thanks a lot. Okay, so let's go with the last speaker of the panel. We have Mirko Meninga ready. He is the Senior Public Administration Specialist and Manager, specialized in public procurement, contracting, pricing, procurement, and tendering systems, policies, procedures, and processes. He is the Head of Procurement and Logistics at ESS. I said it correctly,
Yes.
Mirko?
Yes.
Great. And Mirko has a background in defense, humanitarian, health, and research sectors from the German Ministry of Defense, NATO, UNICEF, UNOPS, and now ESS, so very complete.
Thanks a lot, Javier,
Thanks,
and
Mirko.
the whole CDTI team. And you can say I'm as far away from being a scientist as you can come. And I have to sort my thoughts a little bit because it was mind-boggling, the scientific projects that Luis and Mario presented. And I always think ESS is complicated, but in terms of this, I think we are easier to grasp. We are one site, which is quite big when you walk around. It's around 5 kilometers maybe, but we are not so theoretical, let's say, at CERN. We might become to some extent, but we actually want to look at existing matter to advanced material science, so to develop things for harnessing the power of the sun or store energy to develop new hip implants or tooth fillings, medicines. So it's really material science. So I will try to show you how we try to turn this into reality, and we are actually very close to start the machine and start the process of making this real. So there was no presentation yet on the project, and as I said, I'm not an engineer or a scientist. I will try to give you in layman terms a description of what we are trying to do. So here you see a an image of our target station where we will produce neutrons, and you see a feature around which we call the sombrero, and visitors always ask, is it just a design feature? No, it's also a stability feature in this. So the target station in Lund is the place you want to be when there's an earthquake in the south of Sweden or in Scandinavia. It's the safest place in the whole country, I would say. So ESS was awarded to Lund in Sweden in a competition to Bilbao in Spain. This is why you see another ESS here, ESS Bilbao. I will show more about this. And the third competitor was Debrecen in Hungary. Why? Because there is a smart person in Hungary who was director in our place who actually cracked the code of how you can build a neutron facility that is not nuclear-based and that has a solid target, because SNS has a different type of target, and ILL, the biggest existing one in Grenoble, is nuclear-based. So this is based on a particle accelerator, very much like the particle accelerators in CERN, which accelerates protons. And the award was made in 2009. And then we had something called the TDR, the Technical Design Report, which was a big book where the basic design was created. What type of machine should we have? How is it split up to achieve the power level and intensity we need to create neutrons at the required level? How the target systems have to look to then later get the neutrons into the instruments where the science then happens. So I joined on 1st of May 2014, and that was like 2 months before we put the golden shovel that we still have into the ground. So it was all just a big field, or there was sand. So, and then in 2018, we moved from offices out to the site in temporary offices. And in 2021, we moved into the completed offices at the far end of the facility, which for me is bad. I'm also the head of logistics, and the logisticians sit exactly on the other side of the facility where all the deliveries come in. So I have to sort of be in 2 places, 2 kilometers apart. And at that time, in 2021, approximately, the whole civil construction, which was a big contract, I think actually our former head of legal, Ohad, who is here, he was running that big tender, EU tender exercise. So at that time, ESS was a public company, an AB called in Sweden, and had to follow the public procurement law in Sweden that follows the EU directive. So this was a big EU tender, I think, with 4 big parts. So it was an umbrella contract. It ended up somewhere in the area of 660 million euros. So about 1/3 of the intended construction cost of ESS in 2013 money. So we moved in, and then we got handed over the keys to the site, so to speak. And in spring, we achieved our first big milestone, beam on dump, meaning the full accelerator was on to, of course, a minor effect, very small pulses of the beam sent to the beam dump, which is just straight ahead, a big lump of copper and concrete, I think, because we don't want to produce neutrons yet. But this will happen in March 2026. So it's extremely exciting and busy time. And then we have time until end of 2027 to tune the machine, get the neutron production sort of tuned for the instruments, because on the 1st of January 2028, we are supposed to go into steady state operation. So here you see the machine. As I said, we have an ion source that came all the way from Catania in Italy, where we use hydrogen and electricity to extract protons. And those protons are then accelerated in the particle accelerator that is almost 600 meters long, where we first have a normal conducting sector, and then most of it is superconducting under vacuum, and we go down to 2 Kelvin. So the biggest cash procurement we ever did was the big code box for the accelerator to go down to 2 Kelvin. It was about 50 million euros. And usually when we cool down, which takes about 2 weeks, we first go down to 4 Kelvin, but then we have to go down to 2 Kelvin. And I asked our scientists why we have to do this. Couldn't we save money, because the energy you need to go down to 2 Kelvin is so much more? But they said helium, which we use for cooling, changes property and then flows without resistance. So you need that to achieve 96% of the speed of light. And this is what we will achieve before we then hit the rotating target in the target station, which is a wheel, I think 2.5 meter diameter, and inside are 36 pieces we call the cake pieces, and inside stand 3,300 small blocks of tungsten metal. And out of that, we kick the neutrons. And tungsten has a lot of neutrons, which makes it especially suited. And then we have short instruments and long instruments that are further away. And what we will do is we then have scientists, 2,000 to 3,000 a year, that will place their samples in the instruments. And then detectors will catch the neutrons after they penetrated the sample, and they are neutral, so they will not destroy what we are looking at. And then we will have the data sent to our data center in Denmark, which is the second host country, where they will do pictures, videos, and analyze the data and make it available for the scientists. Wait, I think there was a picture missing, actually. It's not really visible. Well, it's just a picture of our instrument suite. So we will start initially with 3 to 4 instruments that we switch on, but we have approved 15 instruments, and all of them are under construction. We have the test beam line, which will be the very first one, where we will then test the neutron source and see how the production is working. All the other instruments are constructed by our member states. So we have 13 member states, and all of them in Europe. And it's 2 to 3 for construction of every instrument, and based on what the instrument is, a spectrometer, or don't ask me what the others are called, they will be enabling different types of science. And they have all strange names. Visitors always ask me, they're called T-Rex and Odin and Beer and so on. Beer is constructed by Germany and the Czech Republic, of course. And those are not just funny names, they're actually abbreviations for what the instrument will do. So I think it's a combination. You want to have a nice name, but you would also like for scientists to understand what is happening. So, and that said, we are 13 member states from the EU, but we have about 580 employees now, I think. And they come from 60 countries around the world, because like my fellow speakers already said, we share the same challenges, and we have problems that where the knowledge is not existing in any part of the world. So we have scientists, engineers from all over the world, many from the nuclear sector, to make this happen. And we also have the challenge of being an ERIC, which is not an international organization as such. It's a very special infrastructure legal form, European Research Infrastructure Consortium. It was created by the EU to enable rather quick establishment of new scientific infrastructure. We have one advantage, though. The ERIC legal framework says, with regards to procurement, we are an international organization. So we are exempt from the European directive, but just like every other set of procurement rules, wherever I was in NATO, UN, or as it is in ESO and CERN, we have to follow the overarching principles, which mean there is transparency, there is competition, like we have best value for money as our main principle, and equal treatment and so on. So we are not completely free, and nobody who handles tax money will ever do this freely. We don't have a return principle. So the way we were built, as I said, the civil construction was a project in itself. ESS and the winning tenderer Skanska, they formed an own construction company for this. So this was outside of my area. We have all the cash money that we get. This is then under the ESS procurement rules. So we had the possibility to create our own procurement rules, and we became an ERIC on the 1st of October 2015. So the rules have been in existence already over 10 years, and we have modified them twice, which is much quicker than what CERN, for example, is able to do. And we will go into a new revision now, which we have agreed with our owners, because we learn all the time what's working well and what can we do to make things easier for companies, for example, to work with us. And then the third leg, which is equally big, or if not even bigger than the cash procurement, is in kind. So there was no neutron science in the south of Sweden when this was built. So, and how do we do this then? Well, we use the competency in all our member states to deliver technical components to us, like cryo modules. Or ESS Bilbao has delivered the target wheel and the shaft and many other things. So we get deliveries from the in-kind partners we have, and those are institutes in the member states, and they compete for work packages just like a tender, you can say. And then companies always say, oh, isn't there anything in there for us? Yes, of course there is, because they are all public. So they have to tender in their countries. So we have many work packages where a country has taken the work package. We have the casks, for example, for the target station, that the Hungarian partner is doing, but the manufacturing is done by Astor Phaeton Spain because they won the tenders. So it's a lot of procurement in there as well. Unfortunately, not one channel to see all those, which I would like to do often as well. But we try, with the help of our ILOs, like Javier, to promote them as much as possible. So we have, just like any other set of rules, thresholds. So until 200,000 euro, everything is done by direct invitation. Up to 25,000 euros, the projects can obtain the quotes themselves. And then between 25 and 200,000 euro, it's coming and done via my team. And especially interesting, because this is where we have a lot of technical challenges that are not, multi-million problems, but they are very difficult problems we need to solve. And SMEs are especially suited for this, are 50 to 200,000, and those are distributed via the ILOs. So they name companies that we then invite directly via our e-tendering tool. And then we have a principle over 200,000 is open tendering, and open meaning worldwide, so we don't have any restriction. We make then a selection in each tender designed for the case of how does the company have to work, and how big does it have to be, and what prior jobs it needs to have done, and so on, to select tenders. But it's not based on a geographic area, you can say. So use the ILOs is my best advice. So in the past 8 years, which was when the construction of the machine and all the things inside the civil buildings really took up, Spanish industry has been really successful. So apart from the host country Sweden, where you have all the consultants and the installation work, which drives up the value, I would say in technical procurements, it's Spain together with Germany and France that are the absolute most successful. I would say in number of technical packages is actually Spain the most successful. They build almost all the shielding for the target station. We have big modulators for the powering our klystrons, which provide the accelerator with RF power from GEMA. And you see, it's just a little list of all the Spanish companies we have. It's many. And then, as I said, our in-kind partners, of which ESS Bilbao is one of the most important. So they have done some of the most crucial work packages and components for our facility. And they are out here, and they have both a booth, and they have also an exhibition piece for something else. So what will be in there for us or for you in the future? And people always ask me, so then in 2028 you are done and everything is ready and no more opportunities. And I said, no, we will never be finished. So we will go into operation with 3 to 4 instruments, and then we will build the instruments until 15 are complete, and this will take another 5 years. And then we have already planned instruments 16 to 22, of which one is high beam. It's actually for experimental physics, more because we have a scientist from CERN who's driving this, and we have actually already bought some things for us because we know it will come. The accelerator will start with a basic effect, and then we have to upgrade it to 3 megawatt, finally to 5 megawatt, and this will also take another 5 years. And then, of course, we have labs and other scope that has not been completed in this time, instruments, detectors that need to be advanced and upgraded and so on. So there will be continuous needs all the time for the whole future. And then I just got a plan from project division what happens beyond this. So we have areas for instrument rescoping, and of course instruments after some time they will become old and obsolete, and they have to be modified or they're completely removed and new instruments built to be on the edge of material science and to be a world leader in this. So this will also go on. And in this construction phase since 2018, we spent around 90 to 150 million euros a year in cash procurement. And in the future, I think our overall budget will be around 175 million, because then we will be in operation, it will go down. But there will still be an investment volume of 20 to 40 million in the regular budget. And then, of course, if there are new projects, they talk about a neutrino project, they talk about, second target station and a lot of other things. We don't know, but I always say there are many things that we don't even know yet that will come. And then we might need, just like other facilities, we don't have a guest house yet, but we will have 2,000 to 3,000 scientists. And using only hotels is difficult. So we will have that, cryo module repair facility, another target transport cask, which are big structures like the ones Astrofeto is building, and a lot of other things related to the labs and handling radioactive waste. A source test facility is under discussion, which all are very, very complex and expensive things. Here's a list of things that are happening now, this and next years, and we also have magnets. There's 8 Tesla magnet. We just procured one 14 Tesla magnet, and we have cryo, we have vacuum, we have mechanical workshop, and other things that all the other facilities need as well. And just yesterday, I signed another award for Norte Mechanica, actually, for very expensive filters for our target station. So what are our challenges? Well, the things we don't even know yet that they are coming, and they come also now, every day. And often it's someone like the chopper group that says, we have to build this chopper assembly, but we are missing a housing or we are missing a stand. And typically they are complex problems, not, as I said, in the multi-million range, but often involving mechanical work and very specific properties in terms of material, tolerances, and so on. So, and everything we have built, it's the first time. We don't know yet how it works. I always say when we push the big switch, it will be smoke here and flashes there, and then the real work starts of making this all happen. This is the wheel, for example, from the top. So here is contact information, and I know the information will be shared. We have on our website, you see all the ongoing tenders, planned tenders, contact information to us, to the ILOs. We have an e-tendering tool, which is mirroring the information on the website. And there you can go and register. And in case you don't find anything, just contact me or Javi, and we will provide you with the information. That's the tunnel. Thank you.
Thank you, Mirko. In Spain, we are very happy because we have been quite successful, as you said, in the procurements for ESS and also, of course, in the in-kind contracts run by ESS Bilbao. So I think it has been a very good track record, I would say. So what is your feeling about this? It's an organization that works combining these cash contracts run by you and then the in-kind procurements. Has this been a challenge? What can you say about this?
So far, for me, it has been working well because I'm not involved in the in-kind deliveries. But as we have started the machine already to some extent and the target systems are coming, there are a lot of things that we already do that are the effect of in-kind deliveries that, I don't want to say they don't work, they work, but where we already discover that will not be giving the reliability we will need. This will not be 200 days a year of 24/7 running. So there are bearings, there are small motors and things which we already need to find new solutions for. And then one in-kind partner, not the Spanish one, then said, oh, this little motor that is inside the cryo module at 2 Kelvin and total vacuum, that's from a tiny little company in Bavaria in Germany. And I said, oh. And we contact the company, and I can do this in German, of course, and they say, what, ESS, 3.5 billion we will have spent when we go into operation, single failure item, no, sorry, we cannot take this because we cannot give any guarantee. So then I had to convince them to say, we don't want you to guarantee anything. We know you have another motor that will work much better. We want to do a collaboration with you to prove this, and then you can take the data, we can, of course, prove the concept, and you can use this with others. So in the end, we were successful, and a few days after we talked, before we had signed anything, we had already 10 motors free of charge, and the whole thing started off. And this will be the future. So, and this is where the in-kind partners are crucial, so because always people say, then you are in operations, no more in-kind. And I said, ask XFEL, the European XFEL in Hamburg, that also has a lot of in-kind. This would be a dream, or a nightmare, I would say. You can never live without the competence of the partners that have built most of the really complex, big equipment that get their machine running. So I would say, whatever we call it in the future, and we have just highlighted some alternatives to our management, we will have a high degree of collaboration with our partners also in the future. They are also our owners. And we don't have a return principle, but now they come and say, hey, do you have data? How did it go? That's not my mission. I cannot pay someone to pull the data. I do it myself. And the ERIC framework doesn't really foresee this. But of course, as an owner, you want to know what has been coming back. And actually, I have data that shows that we are doing really well in the combination between in-kind and cash procurement. We don't do country of origin anywhere, to lower levels. But from where the contracts and packages have been going, we have done extremely well. So, yeah, I would say it's a model that has worked for us, and yeah, let's see what the Einstein telescope will become.
Thanks a lot.
It will be interesting.
Cool. Okay, so anybody has any questions, would like to make any comments, any feedback? Nobody wants to take the word? We're all so hungry.
So thank you for the very nice talks. This is a question maybe for, what's her name? Professor, yeah, Christina. So looking at the FCC, right? So the FCC as a project, it looks at the timelines are so much longer than what we are typically using in accelerators and in high energy physics. Instead of the 7 to 15 years, we are going to all the way 50 years, right? Now, do you have, you're thinking about some procurement strategies that, other than taking in consideration the lowest bid or the country contributions, et cetera, look also at the possibility of maintaining a long-term relationship with industries so that they can ensure the if you say, either maintenance or, their contribution to the project on a long term. Is anybody thinking about that?
Absolutely. Absolutely.
Thank you.
No, we are thinking about it, and the answer, I'm not going to be able to give it to you today for one reason, is the FCC governance is not clear. So it will depend on the governance, which are going to be the procurement rules that are going to be applicable. What's going to be the preparation for the FCC? We are applying currently the current rules that we have. We are doing site investigations. We are doing plenty of different works already that we are doing it on the rules that we know today. What are going to be the rules of the future? Still open. Of course. We've been thinking, and we've been even consulting different organizations to see what could be. Is it the same model that we've been using? Is it still valid? I'm not able to answer to you today.
Okay, thanks a lot. By the way, the speaker who made the question is Fulvia Pilat, and she has a talk after lunch. She's going to talk about she's going to give us like an overview of the big science ecosystem in the accelerator and synchrotrons in the US. So I think it's going to be very interesting after lunch. So I expect you all here. Thanks a lot for all the speakers. I think it has been super interesting, engaging. I hope it has been food for thought for all the industries here to invest in R&D. I think there was a clear message by some of the speakers, and use the ILOs as well. So thanks a lot.